Hi everyone. In this video, we'll be discussing inverse functions, inverse trig functions, and their derivatives. So, what is an inverse function? Well, if we have a function f denoted by these black arrows, so this function sends this blue arrow to this blue dot to this red dot, and so on, well then the inverse function should just undo what the function did. So the inverse function would take this red dot and send it back to where it came from. So this function does have an inverse, but does every function have an inverse? Well, the answer to that question, unfortunately, is no. So let's say we have this function here. Note that these two blue dots get sent to the same red dot. Well, if we tried to define an inverse function, where would we send this red dot to? Would we send it back to this blue dot or the one underneath it? Well, we can't send it back to both because then it wouldn't be a well-defined function. So unfortunately, this function does not have an inverse. If we notice that the first function sends each blue dot to a different red dot. When a function does this, it's called one-to-one, and one-to-one functions have inverses. So let's think about some trig functions. So let's take cosine, for example. We know that cosine of pi over 2 equals cosine of 3 pi over 2 equals 0. So we know that cosine is not one-to-one because it takes pi over 2 and 3 pi over 2, two different inputs, and sends them to the same output, 0. But if we only put numbers between 0 and pi into the cosine function, it actually becomes one-to-one. So on 0 and pi, we can define an inverse function denoted by cosine to the negative first power. We say inverse cosine, or you might see arc sine written out. And all it does is it undoes the cosine function whenever the input value, in this case pi over 2, is in between 0 and pi. So this will evaluate to pi over 2. So this doesn't only work for the cosine function, it works for all 6 of the basic trig functions. Now, you might ask, well, if a function is differentiable, is its inverse also differentiable? And the answer to that question is yes. So suppose we have a function f that's injective, so it's invertible. Then we take a point x such that x is equal to f composed with f inverse of x, because the f and f inverse undo each other. Well, to find the derivative, we can differentiate both sides of this equation with respect to x, and we get 1 equals, then here we have to use the chain rule. So we have the derivative of f evaluated at f inverse of x, and then we have to multiply by the derivative of the interior function, which is the derivative of f inverse. And then we just solve for the derivative of f inverse by dividing both sides by the derivative of f evaluated at f inverse of x. So it turns out that yes, the inverse function is differentiable, and this is captured in a theorem called the inverse function theorem. Now this also holds for our 6 basic trig functions on the intervals for which they are one-to-one. So I hope this video helped, and happy reading. Thank you for watching.